phasized with what we just saw. Okay, this one is your transmitter, and this one is your receiver. Okay, we have different ways of transmitting electromagnetic wave. Okay, we have the space wave transmission, direct wave transmission without any obstacle, and we do have a refracted wave when there is an obstacle. Okay, and this is the Earth, and then you can see like what's the type of waves transmission method we can go with. Okay, and there's also a ionosphere, okay, that you see. You'll see further on what we're trying to say. Okay, just continue with what we say. The ionosphere, it's the layer that you see between the Earth and the space. Okay, there's a refraction when you send a signal. If you have your receiver that side, your transmitter that side. Okay, and you have all different ways of refracted from ground. Okay, so these are just sky wave. This is a transmission from sky wave. It's the one that you send your information, and then it's reflected by the ionosphere surfaces. Okay, and it's going to reflect your sky wave. Okay, and when there's no refraction, this is what we call direct. Okay, and then this is ground refracted. Okay, wave. That is an example of what you see there. So we have different types of. So this is the same example. Now you can see we have sky wave. Okay, refraction, and we have ground wave. Okay, so you can see this is your transmitter, for example, and this one is your receiver. So different ways of how you can send the signal. And this field that you see here, it's the ionosphere. Okay, and the line of sight is this line here that you see there. And you can see that these are just an example, a ground antenna that's sending information to another block. Okay, and the signal that you see that goes out, we call it penetrate wave. So that's why this block here is the ionosphere block. If the signal goes out of that ionosphere block, it will be transmitted to satellite, for example. Okay, so rocket outside this field. Okay, so now you can see like an example of reflected wave. Okay, there's different layers that we get with the ionosphere. Okay, and this is the ground. The same goes for this image. So it's just to show you that we have a direct wave transmission, refracted wave transmission, and yeah, and the sky wave transmission. Just to keep it short, sky wave with this refraction into the sky. Ground wave, this is a ground wave. For example, this is a transmitter, and the receiver, it's inside this chip. Okay, and the ionosphere field that goes on the other side. Okay, and this is a transmitter and the receiver. Just an example, this is the space. Okay, transmitting from the space. This is when the signal can go out of the ionosphere. This is the ionosphere that you see here. If a signal goes outside of this, we send it to a satellite, for example. Okay, and if it's a direct signal, they're giving you the range of a ground wave. Okay, and the space wave, this is the limit of where the signal goes. If you send the signal with this higher than this frequency, it's gonna go out of the ionosphere. But if you send a signal that is lower than this frequency, it will be kept. It will be reflected by the ionosphere. So, okay, just to give you an idea of what's going on there. And this is what you see, a refraction for the sky wave type of way of transmitting information. Okay. Now you got an idea. This is a Earth ground wave. This is a ground wave, and you can see how the system is refracting. Okay, so this is ground wave. You can send your signal. There's a lost because we have this block here. So signal, you can see the signal is gonna go that side. This is where we have refraction or diffracted radio wave at some point when there's an obstacle. That's what you see here. When there's an obstacle, then we're going to have diffracted wave. Now, this is just an example. Sky wave, when the Ionosphere, it's this field that you see here, that blocked the signal. Okay, and this is the space wave. Okay, this is another type, it's space wave. Okay, when you send a signal from the ground to the space, so we call it space wave. It's an example of space wave. And these are the example of sky wave, the one that you see here, blocked by the Ionosphere. Okay, there's a range for your signal to go out of the Ionosphere. It's if you want to send your signal into the space. And this is like a ground. This is the ground wave. Okay, so you have your transmitter here, and then your receiver this side. So in order for you to send the information, you can see there's a tree. As an obstacle, the system is going to be refracted in different direction until it gets to the destination. Just to emphasize, this is a direct wave you send from the transmitter to the receiver, and this is a Earth refracted wave or ground wave transmission. The same for this. So this is a direct wave transmission from the transmitter to the receiver straight. Okay, and when there is a refracted, that's this what you see. The ground should be like an obstacle, and you can see this is the Earth. You're sending, this is a transmitter, you're sending to the satellite. Okay, space wave. Again, this is space wave, you send to the satellite from the ground. Okay, and this is a sky wave transmission, and blocked by the Ionosphere. And what you see is just the ground wave transmission, giving you multiple path propagation. You can see you can send the signal from the transmitter. This one is the receiver. The signal will be reflected. For example, we got a mountain. This is where you see refracted. The same goes, it can be reflected by the house, building, and this one is the direct transmission, direct wave. As you can see here, this is Ionosphere, and then you can see this one is the sky wave, direct wave, and this one is the ground wave. Okay, just to categorize, when a signal goes out of the sky, out of the sky wave, out of the Ionosphere, we call it space wave, and this is an example of the range. And this is also an example, and another example. But if the signal is lower than this, it should be refracted. This is what we call sky wave. Okay, just to give it a figure that show the refraction of the field. So you're gonna have a sheet material. It's gonna go like there's absorption of the signal. These are like the type of interference we can have when you send the signal. There is a electromagnetic field material that is blocking the signal. So you will have absorption of the signal. So the signal is not gonna be the same as it's started. Okay. We also have refracted wave. It's when the signal is refracted, it doesn't go through the obstacle. Okay, and refracted signal, just to give you an idea. And also absorption, you can see the signal is going to continue, but it's not going to be the same anymore. It's going to decrease. And just to give you an incident wave, how it goes from one side to the other side, so you can get the output. Just to give you a clear idea, this is the incident wave that will be refracted. and when it's been absorbed, then the signal is going to decrease the quality of the signal, and also reflect on the other side. Okay.